Okay, so hello and welcome back to another Unity tutorial. In this one, we're going to be continuing with part 2 of the FPS tutorial series. So we're going to be doing, we're going to get the camera inside the player. We're going to, have it first person. We're going to add a crosshair. We're going to make it so the mouse is locked, so we don't just zip around it. We want to have the mouse hidden in the center, and then we want it so that obviously we can move our mouse to look around and click to fire off raycasts, and then next episode we'll be doing the actual dealing damage by shooting. So this one we'll just do maybe returning what we hit, and then we can create some objects next episode to shoot. And then that'll be basically the main core of an FPS, and then we can obviously build it up, add health bars and add ammo and different weapons, so it'll be pretty fun. Now for this project I've actually gone ahead and put it on my Patreon, and every project from now on will be on the Patreon. I need to adjust the date because it's technically today I've started doing it. So yeah, anyone who is a donator on Patreon that wants access to the project files I'm putting on here, and after every episode I will update the project files. So obviously give this a quick read if you haven't already. I'm not going to explain it fully, but basically I've done it on cloud storage so that if you want to have access to it once you join on Patreon, you can just ask down here and I can add your email from the list of patrons to the link so you can access the cloud storage. So anyway, yeah, I also want to quickly thank where is it? Here we go. Paul Robinson, Phil Bourne, and Wesley, the new donator. Thanks for that. So yeah, if anyone wants to help out, links in the description below. Anyway, code. So last video we got the movement done. Now here is where we handle the actual moving with WASD or the arrow keys. I want to just say, last episode I was going to multiply this by the time.fixed delta time, but I didn't know if we actually had to because I kind of forgot due to the fact that, we are doing it in the fixed update. But if you actually look at this, time.fixed delta time, interval in second in which the physics and other fixed rate things update. Now, to be honest, even if this doesn't really affect it in well, first of all, we're doing a single player FPS. I'm not going to do networking in this, so also Unity's completely changing their networking system, so I don't want to have to relearn anything really quickly to do this. So at least for now we're going to keep it single player, just having enemies to kill, or whatever you want to do for the shooting. But the point is, it doesn't need to be completely competitively accurate. If you move less slightly, I mean, it should be smooth. It will be smooth. And the best thing about timesing it by that number is that it's a small number, so that we don't move super fast like last time. If I press play, if I go to the player, if we go to where they are, we need to actually put this value up right now. That seems a bit better now. Okay, we'll leave it on 3. Whoops, that's 4. That's 3. Okay, so we got jumping and yeah. Okay. So what do we want to do now? We want to add the camera script. So we're going to put the script, well, our main camera is going to be what we look through. So we're going to add the main camera to the player and then put it at 0, 0, 0. Okay, so the camera is now in the player, but in reality, we would like the camera to be at the top of the player. So if we go and put that up to the top, depends how tall you want your character, if you know what I mean. But we'll add it there. It's hard to really tell what's exactly right, but we can go for, I just want a nice number, 0.6. Why not? We'll go for 0.6. Audio listener's fine. Yeah, we've got all the things are fine. So on the main camera, we'll just call it player camera, where we look through. We want to add a script called player, I'll call it camera controller. And this is going to take in our mouse input for how we move the mouse left, right, up, down. Or forwards and backwards, I guess, and that's going to then rotate the character in that direction. Now let's just make sure the rotation's all right. So our player's forward is our camera's forward. I don't think that's really necessary. It doesn't have to be the same, but it just makes sense to be the same. So what do we need to know in the player controller? We need to know serialized field, private, float. We want to have the mouse sensitivity. So I could call it look sensitivity. I don't know. Sensitivity is equal to, well, I'm not going to set it equal here, I'll test it in the playtime, in runtime. We also want a private float for smoothing, so we can decide, how smooth the movement of it is rather than it being completely jumpy. Obviously you can tweak this yourself, so. Okay, then we want to say void start. So in the private void start, what do we want? Well, we're going to be needing to rotate the player. When we move our mouse to look around, we don't want to rotate the camera because let's say, for example, the gun, let's say we're in the player and the gun is, wait, how's that camera looking? Anyway, we've got our gun, right? Like here on the screen, it'll be this kind of area. If we move the camera, we don't want to look here and have the gun over here. We want the gun to be fixed to us. So we want to rotate the player's body, which in turn rotates the camera, because the camera is attached to the player's body in the hierarchy. It's a child of it. So what we want is we want to have reference to the player so we can easily rotate it. So we want to have reference to the game object of the player. So we can store a private game object player, and we can say player is equal to, then if we look in the hierarchy, it's just our parent basically. So we can just say transform.parent.gameObject, because that's the game object. So transform is basically this, the parent of the transform. So if you go in the hierarchy, this is us, the transform, and then we go up one, the parent is the player, and the game object, because we want to store the game object, which is just, a game object is the entire thing, and then we can get components off a game object like transform, camera, audio listener, and then our custom scripts. So we're storing that, and then in the update, we want to have a function called like rotate camera, which we're going to write. Obviously, as I said, it's nicer to have your functions outside outside of the update, just to make it a lot easier to read. And then if we add other functionality in the update, we don't have to just add more junk into here. We can split it out. It's nicer and it's better practice. Now, what we're going to do is we need to get a value, or two values, one for our X and one for our Y input. So obviously X input would be when we move our mouse like this, and Y would be like this. So if I move it up, it'll be positive, down negative, left negative, right positive, and so on. Now, if it's two values, we could store it in a vector too. It makes the most sense because, or we could just have two separate values, because I guess it makes more sense to store it in a vector too. It just, use less space than having two variables. It's better to have one. So we can say we want a vector2 to be equal to vector2 dot scale. So as you see, multiplies two vectors component wise, and then we're going to pass in our two vectors. So what we're going to do is, wait, is this the right no, sorry, this is the wrong thing. We want to pass in this is the wrong part. We want to do vector2, and then we have to give it a name. So we'll just say input values. We can change names later. And it's a new vector2, because a vector2 is a struct, and we have to make a new struct right now. If you don't know what that means, I've got a video on structs. You can go back and watch that. Vector2 is just an inbuilt struct. We'll use vector freeze a lot more, but this just needs an X and a Y. We don't need a Z. So, or it's technically a Y in this, but we're going to treat it as a Z, basically. So, what we want... Actually, no, sorry, we're going to treat an X and a Y, because, yeah, it's fine. Dot get axis raw. Now basically this we pass in a name in a string, so mouse X. Now if we go back and look, let's just do the Y one, input dot get axis raw mouse Y. Make sure you do it exactly how I've done it. Oh wait, apart from I've done something wrong here. Wait, why didn't I type input? No, I put a bracket there. I'm so idiot. I'm so idiot. I'm so stupid. There we go. Okay, so what this is doing is it's going to go find mouse X and mouse Y and get those axes. Now, if we go into the project, assuming you're on the same version of Unity as me, you can go to Edit, down to Settings, and we go to Input, Axes, and we put in mouse X and mouse Y, which you see here. It's one of the default inputs just for your mouse X and Y. We don't have to set any of that up, it's done for us. So we get those values. Obviously, if I don't move my mouse at all, these values will be 0, 0, 0, 0 every frame. But as I move them, they'll become different values, and then we can rotate dependent on those. So now we can say we want to scale these values that we've got to our input sensitivity, because we want... well, sorry, the sensitivity and the smoothing. So what we can say is we can say input values equals vector2. So it's a vector2 still, because we can set it equal to new vector2. But this vector2 vector2.scale, which is what I was meant to do earlier. So we pass in 2 values, so it can scale it between the current thing, so input values, like so, comma, and then it needs to take in another vector 2, because remember input values is vector 2, and then a new vector 2 in here, and we're going to pass in sensitivity times smoothing, and then it needs a second parameter, but it's just going to be the same, because we want the up and down to be the same as the left and right sensitivity. If you wanted it to be different, then you would change that here. So we'll go look sensitivity times smoothing. Keep in mind, there's different ways to make camera controllers, but I've seen plenty in the past, and after I've looked through loads, this is the one I usually go with. I find it's the best that I like using. So now we're going to say we want to have some new variables. We want a new vector 2 here. So we're going to have vector 2. So this is how we're going to do the smoothing. So like, this is just for getting values scaled, but we actually want to make it so that if we move our mouse, we don't want it to be a sudden jolt, or like when we finished moving our mouse, we might want a slight kind of slow down period, so it's not stuck to our mouse as such. You want it to be a bit nicer to use. So what we can use lerp. So rather than going straight to the value, we can go part of the way. That's what lerp does. Now, I haven't done a video on lerping, but you can actually go and find that. It means linear interpolation, and it's just a way of going between 2 values smoothly. So we can say vector 2 smoothed. Is that right? Is that the right word? Smooth velocity. Tell me if I'm wrong. It's mathf, so it's a math function, dot lerp. We're going to pass in the 2 values, and then the third is the how far between. So we can say we want to pass in our current value, so smooth velocity dot x. I should probably have actually declared this somewhere else. What did I call it? Sorry, smoothed velocity dot x is equal to smoothed velocity dot x. There we go, comma, and then our input values. So input values dot x. Whoa, it's changed it. Input values dot x. And then this is how far between the 2 values we want to go. So we want to use our smoothing value, but we can't choose the raw value because the raw value could be greater than 1, and this is between 0 and 1, this value. So what we can do is we can do 1 over. So we can say 1 over. Now we could just write 1, but the problem is it would treat it as an integer. We want to use a float, so 1f, divided by our smoothing. And then we can do Control D to duplicate and just change. So it's y is smooth velocity y, comma, input value is y. So this is to handle all the y. Okay. And then now all we need to do is we need to then have another vector we need to store actually, which is our current looking position. And we need to then add to that. So let's call it current looking pos. So we can then say current looking position plus equals smoothed velocity. So basically what we're saying, let's split this up. So this is just getting input, right? We're storing our input. So if we move our mouse, we want to know what to do with it. Then here's where we handle it. So this part here is literally just for scaling our input down to be, as you see, it says component-wise. So if we give in values that are of a particular scale, it'll make our values, let's say this is 10 and 5 and you scaled it down by a certain amount. They would still be the same distance apart relative, but not the actual same distance apart. They would still be, like 10 would still be double of 5. It might go down, so obviously it was easy numbers. If it was 10 and 20, it would go down maybe to 5 and 10. It would still be half. So it's the same percentage you're looking. So obviously if I move my mouse up and right to a bit, it's still going to go up and right a bit to the same, just maybe not as far, if you know what I mean. And then this is for smoothing it. So we'll say we want to take the, we want to go between the current value, whatever we're currently at, whatever that is. So by default it's 0, you know, but as we move it'll change. And we're storing it here, we're caching it because we need it every frame, right? We don't want to reset and get a new one every frame. We want to go off our last frame. And then we want to go between that and the value we're actually trying to move to because of our input. And then the smoothing decides how far we actually go to it. So if there's no smoothing, then it will instantly go there. And if there's really high smoothing, it'll take a long time to go there. Because as you know, in a division, this is the denominator. So the bigger this is, the less of an effect it has overall. So it's going to slow it down if you have a big smoothing. So that's just simple maths, I guess. And then this is just taking our current vector 2 look position, and we're going to add our new one. Now keep in mind, just because you're adding something doesn't mean it's going to get bigger forever. This could be a negative if you're looking down left, and it's going to actually, technically it's going to subtract. I mean, it is adding, but if you add a negative, it's the same as subtracting. And then now that we've got this value, this is just all calculation for where we want to look. Now we want to actually do the looking. So we'll say transform.local rotation. So this is the rotation of the camera, okay? We want to, when we look up and down, we want the camera to rotate, but when we look left and right, we want the player to rotate, okay? We don't want the player to rotate when we look up and down, because then the player would start, you know, spinning around, and we would just be like this. But for the player, it's just compiling. So we don't want to like rotate the player like this when we look up and down. That'd be a bit silly. We only want the camera to, like this. So we can say, we want to set this equal to, and we need to use quaternion, which is a data type. It's a struct, as you can see. That's the type it takes in. And I am not a mathematical genius I mean, I don't know what quaternions actually are. I've just used them enough to know how to use them. We're going to pass in the, we need to pass in some values. So we're going to pass in our current looking position .y, but we want the negative because we want it so that when we move the mouse up, it goes up and goes down. Otherwise, this would actually be inversed. We have to make it negative so it's correct. And then vector3 dot right. Now, I'm not actually going to go into the maths behind how this works. Oh, wait. No, sorry. Quaternion angle. Quaternion is the type dot angle axis, sorry. So it explains it a little bit here. A rotation around a particular axis. So we're going to rotate that much around the right axis. Now, I don't know if I can really explain it very well in here. Alright, think of it like this. Alright, so here's the player, and here's his right axis, okay? Here's the right. Now think of it as if you drew a line across here, okay? We're going to draw a straight line across the screen like that, okay? So if I just take a snipping tool, this would be a good idea. So if we had this, here's the right arrow, yeah? Here's the right arrow. So we're going to take a line across here, so we can go all the way across. We want to rotate the camera up and down, kind of like this, if you know what I mean, like around the bar. Now obviously this is 2D, but what it would do is it would kind of go over it and behind on the back, over on the front, behind on the back, which is what we actually do here. When we rotate on the axis, we're spinning around it, okay? So that's what it means. And then we want to then rotate the caret. So this is handling up and down looking. We want to rotate left and handle left and right. Sorry. So player.transform.local rotation is equal to quaternion.angle axis, and we're going to pass in the mouse looking position dot x, so that's left and right, and then player.transform dot up, which is the up vector relative to the player. So if the player's on his side, but the player won't be on his side, so it'll be fine anyway. It's always going to be up. Now obviously you could go and look at that. If you looked at the player's up vector, if we go look at the up vector, so go to the player and go to the up vector, so if we press W, that's the up one, which is an arrow going straight up, and when we spin around it. We spin around it as if we're spinning that point, like it's like a spear through the middle and we're spinning around it. That's a weird analogy, but it works. Now, we've actually done all that. So, if we go back to the play camera, we have a look sensitivity and a smoothing. Now, I don't know what values are right for this, so we're just going to tweak it. So, we can say 2 and 2. Now, as you see, if I move around up and down, left and right, it actually works really well. Now, if I put smoothing to 0, it actually doesn't go anywhere. I would need it to be at least a value, so 0.1 would work, but it's extremely slow. I think I had the numbers the wrong way around. I meant, so yeah, it's the lower the number, the more smoothing, actually, in this case. You could just invert that, but yeah. Now, the only problem I'm having is the cursor's visible, right? And it's not locked, so I can't really do this properly. So what I want to do is, oh, so I can also move around. Now it can jump. There's not really anything to see that it's happening, but it is. I mean, you can kind of see there. So if we go for 2 and 2, we want to also say in here on the start that the cursor.lock state is equal to cursor lock mode.locked. Now locked. What that means is the cursor's locked to the center of the screen, which is what you want in an FPS. And we can also say cursor.visible is equal to false. Now we can tweak that later. Maybe we want to set that visible and unlocked when we go into our inventory, if there's an inventory or a shop or something. But for now, it's just going to be locked like this. So it's locked. We can look around. It's locked. Okay. Press escape to free your cursor and then just get out. And then we also want to go and add that crosshair I added last time to the canvas. So we're going to right click UI canvas. Scale by screen size. 1920 by 1080 because that's the screen size resolution I'm using. And we'll just set this to 0.5 just so it's halfway between. Just ignore that for now, that's just UI, but we don't have any UI. Apart from the crosshair I'm going to add. And there we go. I just made it. Here's what I made earlier. It's just 4 different image components that are all put together to make the crosshair. Just something simple I made. So now we can press play and you'll see that we've got a crosshair. We can look around and there you go. And we're going to add shooting next. So what we're going to do now is we're going to quickly finish off with the raycasting because we have time for that quickly. So what we need to do is we need to quickly say, I'm just gonna really quickly add this, and then next time we can actually improve on it. So play camera controller, we want to say rotate camera. Let's have a function check for shooting. Now, I mean, we're not going to handle shooting here eventually, but just for now, check for shooting. So I've already done a raycast video before, but what we want to say is if sorry, it used to be a private void. Okay, if input dot get mouse button down 0. So if we press the left mouse button, that's saying if we press the left mouse button, right mouse would be 1, middle is 0 is 2. I think it's that way. So yeah, if we press the left mouse button, then we want to say we want to do a raycast. So we can do I don't know, physics. Well, it's a boolean, so we'll say if physics dot raycast. Then we can just say let's store a raycast hit what I hit. That's what a lot of people seem to call it. When I was learning, I don't know, I've got used to calling it what I hit. What I hit, comma, it takes in a distance. So, well, there's other things it can take in with a raycast hit, I think. Or denominator. I seem to forget actually what order people pass it in. We'll just say we want to go transform one of the cameras, so transform.position, transform.forward. We want to go for so you can actually just do it with this with an origin and a direction. We should also pass in a distance. So well, for now we can just say mathf.infinity, which just basically says it'll go on forever. Obviously infinity doesn't exist as such, but it's a representation of infinity. So we're going for from the camera's position forwards for that long, and that works, but we actually want to pass in, I'm sure you can have, where do you actually put it? Is it here? I'm sorry, I'm just forgetting where it actually goes inside here. Is that it? There we go. Sorry. So we're going to basically say if we fire a raycast from our current position forwards for that distance, we can just have a distance if we wanted. We're going to output any data to this variable. So I can say debug.log what I hit dot name or collider dot name. Okay. So basically, whatever we hit, we're gonna say its name in the console. Now, I'm usually stay away from console stuff, but this is just something quickly for the end of the video. So if I now go to the player camera, I don't really need to do anything on the player camera. all I need to do is, I guess, just for the sake of showing that it works, if we go to here, I'm just going to quickly go over here and add a cube in, 3D cube, and just put it at 0, 0, 0. Then move the cube actually to 1 and just shove it over here. Alright, so if I duplicate this, so I have 2 cubes, and this one's called Bob, and this one's called Bill, just for an example. And they have colliders on. By default, boxes, cubes have colliders, or any shapes have their mesh colliders, I think. So if we press play and then we go to the console, okay, we're going to shoot the ground, floor, 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 floor. Shoot on this one, Bob, 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 Bill, 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 Bob, Bob, Bob. You get the idea. So that works. Okay, that's pretty much the video over. Obviously I quickly just added in shooting at the end, but next video we'll separate the shooting to its own script. We'll handle shooting enemies with some health. We'll just have like a dummy health variable. We'll shoot them till they're out of health, and then they'll die and they'll be destroyed, and then we can continue from there on. Obviously leave your ideas in the description of what you want to cover in the next video, but obviously I have a kind of plan of what I want to go for anyway. If you made it to this point, obviously thanks for watching. If you haven't already liked, subscribed, it would mean a lot. Help me on Patreon if possible, to have access to the project file as it gets bigger, or just to follow along and check your code against mine or whatever. But yeah, I don't think there's anything else to mention, so just stay tuned for more videos. Thanks for watching, and goodbye.